Hi guys, today I would like to demonstrate how to use LSTM model, which is a deep learning model, to make the prediction of the next word. So the prerequisite to this is you should be having the basics of LSTM. So if you do not know what is LSTM, you can refer our video in the channel, which is describing what is LSTM and the application of LSTM with one example. So there is a video on LSTM. So in this session I would like to demonstrate how to build an LSTM, and we have some sample data, email data. By using that email data, the model is trained, and once the model is trained, it will make the prediction for the it will make the prediction which is the next word. So at first we'll load the libraries. We import the libraries like importing NumPy here, random to generate the random data, importing pandas, importing sys, operating system related functionalities, time, codecs, and we're also importing collections. And our model is sequential, means the layers are added in sequence, and we are importing the layers like dense, which will give the output, and drop out to drop some percentage of data, and then LSTM, the important layer for LSTM model. And we are also using callbacks to stop the training once the goal is achieved, and we are using NumPy utilities, and tokenizers are imported like sentence tokenization and word tokenization, and we are also importing SciPy for text processing. And this is the one of the tokenizer, talk tokenizer, importing the Lagrange expression and then creating object to the talk tokenizer. Okay, so at first the libraries are to be imported. So I'm running this cell, then the libraries are imported, and then so this is the data file which I kept in my data folder. So it's a CSV file reading and specifying the encoding type, and there's a column v2. From the data frame we'll be getting the column v2, that is the email data, and converting this data to the list. So email data dot values dot to list, and then displaying the data. So here you have list of sentences, understand, list of sentences as the output. So after that what we do is we convert this list into strings. So because we need to do the text processing, so from collections.abc importing iterable to get the sentences or words in loop manner, and we are defining a method here, flatten, to flatten the data. So when you call this method, it will give us the items from the sentences, means words. So for x in items, so items is the input to the function parameter, and if it's instance of iterable and not in a string of bytes, so then we'll get the text from that, else we'll get the x. So this is done, and now we are calling the above method. So text data is equals to list of, flattening the data, so calling the function and passing the parameter list data. So list is given as input, then all this data is joined with the space, blank space, and then we have to do the pre-processing. So we are adding backslash and replace with null. That means converting all the unwanted lines and converting the text to the lowercase. So because capital character and uppercase character makes the difference, and if you have other than this small a to z followed by capital A to z and also digits and space, so we want to filter them. So other than these are removed, and then we are doing the tokenization. So we have already created an object to the tokenizer, then passing the text data as parameter to the tokenize function. Then this is list comprehension, then we'll be getting all the tokens, means the words, and we'll get the dictionary words. I mean we get the distinct words and we sort them. So word count is equals to collections dot counter, getting the length of counts, getting the length of words, and then printing the length. So totally we have these many words, 9620, and this is list comprehension to get the most common words, so distinct words, and also we are sorting them and converting the result into the list. So this is the length of our data, so or we can say dictionary. And then we'll get the indices for all these words. So this is no dictionary comprehension x, and I is the input for I, and x and enumerate from the distinct words. We'll be getting the words, and we are deciding the sentence length to be 25. That means we'll fetch 25 words from the test data, from the data set, and then we'll make the prediction for based on the 25 words. We'll predict the next word. And then we are preparing data for modeling, so we are creating a list here, input data and output data. So input data means which is the input sentence to the model with the indices, and output data stores the indices of the output of the model. And writing a loop here for I in range of 0 to the length of the sentence. This is slicing, so starting to end, then getting the features, getting the words x comma y. So once you determine x and y, we append it to the input data, and we append x to the input data, and we append y to the output data, and then we are printing what are these. So these are the indices of the input data and output data. Then generating x and y here, reshaping this into the array that is two-dimensional. And then now we are building a model, so we have to define a model. So this is LSTM model, so creating object to the sequential class. So our model is sequential, which means the layers are added in sequence. So at first we are adding LSTM layer with 256 neurons, and specifying the input shape and the 20% dropout, and getting the intermediate getting the output based on the Y shape. And the activation function over here is softmax. So once the model is defined, you need to compile. So while compiling, you need to specify what is your last function. So last function is this categorical crash entropy, because we have multiple outcomes. Otherwise, if it is a binary classification, we have to use binary crash entropy, and the optimizer used over here is Adam. And then we'll save the checkpoints, so we are specifying the number of epochs here as 5. Then for these epochs, we'll be saving the checkpoints in the HDF5 format, and we have to use that file. And then model checkpoint is this, monitoring the loss. Verbose 1 means we'll see the output. Save best only true, and then mode is min, and then specifying the callback here. Then the data is fitted to the model, and model is going to learn from x and y. So here you can see the number of epochs we have mentioned 5, and the batch size 128 means at a time 128 words or tokens are given to the model. Then it is going to learn from those 128 batch of data, and here we can monitor a loss with respect to each epoch. So initial loss is this much, 7.8100. Then for epoch 1, it has saved the file. This is the file here, and in epoch after epoch 1, you can see the loss is this much, and the loss is reduced in epoch 2, 6.83. So we need to have a patience over here, because it takes time. Of course, we have smaller data, but when you have larger data, it could also take a lot of time. So that's why we have reduced the number of epochs here. You can monitor the loss here. So loss is getting decreased. So 6.8369 to 6.7035, and after epoch 4 it is going to decrease as well. Yeah, after epoch 4, 6.5995. So we are running epoch 5 by 5. So you can improve this model, you can add the number of layers, right? So you can optimize the model for better performance, for better results, and you can use the file, the last epoch file. Just make a copy of this and specify over here. So we are loading the weights of the model and then compiling the model. Then we generate some random sequence here. So we are generating the random sequence by specifying the indices of the input sentences, and we are using our model to make the prediction for X, then getting the indices of the words, and we are printing the input sentence and then what is the index, right? So then we convert these indices back to the words, because we have to know what are the words. So and the predicted word is this. So converting this token back to the indices, and then this is list comprehension, so getting the word of the particular index, and we are now printing the words, and then what is the predicted sentence here, predicted word. So these are the 25 words. So for these 25 words, the model has predicted the next sequence word is 2. So as the words are given and randomly, so you can get the different word. So next time you might get another word. So this is how the model is trained, how the LSTM model is trained to make the prediction for the next words. So based on the inputs, you can make the prediction of the next word. And the point to be noted is here the word predicted is 2, and we give 25 words input, 25 words as inputs to the model. So model has been trained on small data sets. So make sure you have a great computation power, and also you can increase the data. So based on training, if the data model learns from more data, so if you feed more data, so model performance can be improved. So here we took a small data set and I tried to show the predicted word. So that's it from this video. So if you like the video or if you like the demonstration, please do subscribe our channel.